So in the now the last 5 6 years, what we have to create, like we have hosted our virtual machines in the cloud platform. Like this is the virtual machines, and on the top of virtual machine we have deployed our application. Like suppose we have deployed our Jenkins application on these virtual machines, and then we can able to access via the public IP. Okay, but now in the Kubernetes, what so in the Kubernetes, what we have taken one virtual machines. Like in this virtual machine we have assigned some RAM, CPU, and on the top we have deployed our pod. Okay, so this is pod is a very lightweight machine. Like pod you can say is a logical virtual machines. So here we don't have any dependency on the operating system. Suppose this is my virtual machines. Okay, this is my virtual machine, and in the virtual machine we have OS, RAM, HDD, hard disk. So we have deployed only one application per virtual machines. But here in the Kubernetes, what we have used one virtual machines as a worker node. So here we call as a worker node. Worker node is just like a virtual machines, and on the top of virtual machines we have deployed our application. So application is just like a pod. You can say pod is a application where we can deploy our Jenkins pod and we can access. Okay, suppose this is my physical laptop. Okay, and here I have deployed the Jenkins application. You can see here Jenkins application I have deployed on my physical machine. Okay, and now I'm going to access my application. So now you can see my application is accessible. Like this is my server. You can say call this is server, and if you see this is the way like we can install our Jenkins application on the window machine. And this is the requirement, like hardware requirement. You can see like 4 GB RAM at least we have to uh, deploy our application. So in the document there says 4 GB RAM. Okay, so same application we can deploy our in Kubernetes, like you can say like 550 MB or 100 MB, because 100 MB, because we don't have managed the operating system. Because here the 4 GB of RAM, the laptop or the server having own operating system. The own operating system also required some memory and CPU to boot up the application, and on the top my application is also running. So that's why they need the more configuration. But in the pod we don't have managed the operating system. There is no dependency. Okay, there is no dependency of the operating system. It's a very lightweight. Like we can create a manifest file, and we can manage through the image is called like uh, source code. Like image, the application, suppose we had deploy some e-commerce website, so the developer write a code and they can bundle into the var and jar file, and by using they can create a docker file. From docker file we have created the image. So here we can see for this application we need 4 GB RAM, and the same application I am going to deploy in the Kubernetes. Okay, you can see how many MB required to come up this application. Okay, so now I'm going to deploy this. So don't worry, I will explain. I just show you what is pod, why this use, what is the importance of Kubernetes. Okay, so my purpose is showing this the importance of Kubernetes. So I will explain each and everything, the YAML file, what is manifest file, what is image. Okay, so I have already created the Kubernetes cluster. The code. So now I'm going to connect our Kubernetes cluster. My screen visible, right?
Yes, yes.
Yes.
ctl get pod.
Tariq, so pod basically means an application that is running, basically a container, is it?
Yes, pod is just a container, like it's called application, or you can say the virtual machine. Okay, so
Okay.
in this pod you can create a PVC volumes and the service. So I have created one Jenkins application. I have one Jenkins application I have installed on my laptop. Okay, and one Jenkins application I have installed as a pod. Okay, now I'm going to access this application. So this thing will explain. I just trying to understand what is pod and what is the purpose of Kubernetes, what is advantage, this thing. Okay. So here you can see my Jenkins also working here. The Jenkins application is accessible, and if you see the how much memory consumed, so this is the command kubectl. Let me increase the font size. kubectl get pod. So kubectl get pod, it will list all the pod which is running inside a cluster. kubectl top pod, they will show like how much memory and CPU consumed by the pod. So you can see here they are 800 MB. So the application which is running over the virtual machine, they consume 4 GB of RAM. Okay, and the same application running as a pod, they consume only 800 MB. And here you can see only 50 50 M CPU cores they required to boot up this application. So, but if the application running as a pod, so you can save a lot of infrastructure costs like the CPU and memory. So that's why now all the company migrating our all the application from the application running as a in a virtual machines or running in the other way, they can migrating all the resource in the Kubernetes like as a containerization based application. So this is the advantage of Kubernetes. Like you can see, they don't need the operating system to boot up this application. So in the one virtual machine, you can create 100 plus applications you can deploy, but you have to make a heavy worker node. Like you can assign 100 GB memory, you can assign 200 GB memory, then you can deploy more application over the worker node. Okay. So here what in this case, like you have to manage operating system, you have to patches the operating system time to time during the upgradation. You have to impact your application also. There is dependency with operating system, like sometimes your operating system has been crashed, then your entire application will be down. But in the pod, if there is no dependency with the operating system, and like if operating system crash or any you don't need to patch the operating system, there is no dependency with the operating system. Okay. So that's the it's very more advantage of Kubernetes. Like there is no dependency on the operating system. We don't go for operating the patches. Okay. So this is the advantage of Kubernetes. Like it's a very lightweight of the application. Okay, in a single worker node you can deploy multiple application, multiple project. Okay. So in the Kubernetes, let's we have to understand about the architecture, like what is the architecture of Kubernetes, what all the component. So in this topic we understand what is pod, why we need Kubernetes. You understand?
Yep, getting a picture.
Yes.
Yeah. So I have also set up the application which is on my laptop also, and the same application I have set up as a pod also. So this will get a better understanding like what's the difference between and the earlier like what we have managed the application. Okay, now let's talk about the architecture. So suppose this is our Kubernetes cluster, and there is two components. One is control plane and second one is worker node. Control plane, or we can say this one master node. And this is worker node. So there's two component in the Kubernetes. One is control plane and second one is worker node. So in the control plane we have I think four component. One is Kube API server, second is etcd, second the third one is scheduler, fourth one is controller. And in the worker node also we have three component. One is kubelet. So this one also very basic, like the interview also ask about the architecture of Kubernetes. So you can explain like there's two component, one is control plane and second is worker node. So in the control plane we have four component. So I will explain what is the use of this all the component and what is the purpose, what is the significance. So everything will explain. So in the worker node we have one component kubelet, second one is kube proxy, and third one is container runtime. And here one is the agent, the kubectl. kubectl. So here first we can understand kubectl. So what is kubectl? So kubectl is a plugin which we can help to connect our cluster from my local machine. So if you see here, this is my local machine. Okay, this is my just like a virtual machine I have created. So can you allow someone, like someone want to join? Okay, so kubectl is just like my agent. Like we have to install this kubectl plugins in my laptop, in my virtual machines, and from there we can able to connect our Kubernetes cluster. So you can see here I have installed the kubectl plugins in my jump box, and we have to run this command kubectl get node. So if you run this get node, node means your worker node. So here the worker node is used for to run your application. Like in this worker node you can deploy your application, you can run your pod. Okay, so here you can see the kubectl plugins. And in the first we talk about the master node component. So there are four components. One is API server, etcd, scheduler, and controller. So API server is just like the entry point of the cluster. Like any, if you want to access the cluster or if you want to talk between these all the component, so everyone go to the this API server. Everyone go to this API server, then API server talk with this all the component. So these component they can't directly talk with all the component. Okay, so every traffic goes via API server. Every traffic. Okay, so this is the entry point and exit point. So every communication traffic goes via the API server. This is the entry point of the cluster. And the etcd, so etcd is just like a logical container. They contain the all the information about the cluster, the manifest file. Okay, let me show you the manifest file somewhere. So this is the manifest file, so I will explain later, like this one. Just for understanding this architecture I am just pasting here. So the etcd, like what you have deployed all the pod, so everything, this all the files are stored in the etcd. Like when you deploy this pod, so this information is stored in the etcd. Okay, so all the information about the service, pvcc, so every object which you have created in the cluster, so they can store in the etcd. Okay, so this is the purpose of the etcd. And the scheduler is to help to schedule your pod to the worker node. Okay, suppose here you have worker node. This is worker node. So understand worker node. What is worker node? So worker node is the virtual machine where we can deploy our application. My pod is running over the worker node. Worker node is just the virtual machine where we can deploy our application. Okay. And the master node is also the virtual machine where these are the components. These are the responsible to run our pod or application smoothly. These are the components which are run in the backend of the Kubernetes. Okay, so scheduler, what scheduler, they can contact to the kubelet is the agent which is run over the worker node. So if you have 4 worker node, then the kubelet is continuously talking or continuously running over the worker node. They can just check the health status of all the worker node, like which worker node is healthy, which one not healthy, how much space are available over the worker node, how much memory are available on the worker node. So everything they can monitor through the kubelet. So kubelet is responsible for to monitor all the worker node. Okay, so the scheduler go to the API server and API server go to the kubelet and check which worker node have a capacity to onboard the application. Okay, suppose we have there's 3 worker node in our cluster, and we have deploy our pod here, 1 pod, 2 pod. Suppose this node have fully utilized like 90%. And this one only having 10%. Suppose this is scheduler, like suppose one of the customer want to deploy the pod. Okay, so they have to run this manifest file. So they have to run this manifest file. So the scheduler go to the kubelet, like scheduler go to the kube API server, like I have requirement to deploy this pod. Okay, so the scheduler go to the API server, like we have requirement to schedule, we have requirement to deploy the application. Then they go to the API server, then API server go to the kubelet, and then kubelet check the status of all the worker node, like which worker node having the much capacity, like these 2 worker node are overutilized, so we don't have the space to deploy the pod. So they have to go to there, like so they just send the information like this worker node 90%, this worker node 80%, this worker node at 10% utilization. This information they send to back to the scheduler. So scheduler will check like which worker node have a more capacity, so they can schedule the pod over this worker node. Okay, so this is the task of scheduler. So they get the information from the kubelet, like which worker node have a more capacity to deploy our application. So on the basis of the utilization they can schedule the pod on the particular worker node. Okay, and the controller is just they can like what we can say, like if you define the replica tree, like how much the actual requirement and desired requirement, so they can fulfill this requirement. Like if the customer want to deploy 3 pods, so controller makes sure like 3 pod will be scheduled over the worker node, like 3 pod will be created. Okay, so they can see, they can make sure like how much requirement they are getting and how much we are fulfilled in the Kubernetes cluster. So those thing controller manage like the actual demand and the required. So suppose we have we have demand like 3 pod, so controller makes sure like 3 pod will be created over the cluster. Okay, so these are the main tasks like the etcd scheduler and the controller, and API server is just like entry and exit point of the cluster, and kubelet is just monitor the health status of all the worker node and they can pass the information to the API server. So the same kube proxy also, proxy is responsible for the communication between the pod to pod, because in the cluster you have multiple worker nodes. Okay, few pods are running here. So in the worker node you can see so many pods are there. One pod's running here in different virtual machine. One pod is running in different worker node. This application running in different worker node. So how they can communicate each other? So these are responsible for kube proxy. Like kube proxy is used for the communication between pod and pod to pod communication, node to node communication. So they are responsible for network traffic. Okay, and the container runtime is responsible to deploy the pod, like the activity, if you want to stop the pod, if you want to delete the pod. So this container runtime is they have this task, like the container runtime will do the start and stop the pod, they can help to create the pod. Okay, suppose here I'm going to delete this pod. So kubectl delete pod, and you have to define the name of the pod. Now it's deleted, but it automatic created because of controller, because we have defined the replica tree. If you see here, it automatic created, see, 12 seconds ago. So this is the main and advantage of this Kubernetes, like auto healing. Auto healing means if you suppose if you accidentally delete your application, or your pod is deleted, then automatic they can come up. Right here you can see I have deleted this application, they automatically run up. So this task is responsible for controller, because controller is because in the manifest file we have defined the replica tree. It means 3 pod is creating. So controller makes sure like what is the requirement and what we are fulfill. Okay, and this information is stored in etcd. Okay, so here the important question is like um, suppose your scheduler will be down, so what are the impact over the pod? Tell me the answer. Suppose you have already applications running over the cluster, over the worker node, and your scheduler is down, so what are the impact over the cluster, over the application?
They won't be auto healing.
No, no, come again, what's your answer?
They won't be auto healing. Like their replica set is 3. If you delete a pod, there will be only 2. The third one will be deleted permanently.
No, scheduler means
Also, we
like
might not be able to onboard.
mm-hmm.
Yeah, also, we might not be able to onboard new apps, right? Because
Yeah,
scheduler is
right,
supposed to come.
correct.
Right?
So you don't so if scheduler down, you don't onboard a new application, because this is responsible to onboard the application. Okay, so the same, if etcd down, what are the impact over the application?
If etcd is down, I think it'll be like a big impact, right? Because I know I'm just guessing because it has the configuration file. So probably whatever is running, but nothing new might come up, right? Because maybe controller is impacted, then maybe scheduler might be impacted because I think it has to refer everything config from etcd, right?
Yeah, no, actually what if etcd down, so there is no impact
Hmm.
over the application. Okay, so once you restart the application, okay, So once you restart the application, so the API server go to the etcd and check the status, what is the status of the pod. So at that time the application will be impacted. Understand?
Right, right. So when whatever is running will not be impacted.
Yeah, running will not impact, but when you are going to restart, suppose your pod is deleted accidentally, so at that time the
Right,
application will be down, because they go to the etcd and check the status. They mention the three replica. Then if etcd not down, then three pod will be automatic created. But here what,
right.
etcd down. So if the running application, there is no impact. But if the application deleted or restart, at the time it will be impact.
Right. So whatever I deleted, restarted, or even if I want to, let's say, onboard a new service,
You are on board also, because you are not able to save the here, no? You are not able to save the
etcd.
manifest file in
Correct, correct,
etcd.
correct. Yeah, correct. Yeah.
And the same also the kubelet. If kubelet down, then your worker node down, entire worker node down. So what in this case?
Kubernetes keeps track of all this, all the health of the worker nodes, right?
Mm-hmm.
So if perhaps I don't know, like if it's only keeping track of the health of worker nodes, then it's going to, maybe what is running might not get impacted, but perhaps any upgradation, any CRUD activity that you need to do, or any service that wants to interact with kubelet, all of that will be impacted. So maybe onboarding service, bringing down a service, yeah, particularly onboarding or upgrading service, maybe.
Mm-hmm. Now if kubelet down, then it means the whole in worker node down, and all the applications running over this worker node, they can transfer to the other worker node. Okay. So let's see here. I will show you kubectl get node. So we have two worker nodes right here. One is 6 and one is 7. Okay. So kubectl get pod hyphen o wide. So by using this command, you can see like how much which pod is running on which node. Okay. So this one. So here you can see this is my pod kubectl get pod. This is the command to get the information of all the pod, like all the pod is running or what is the status of the pod. So you can see the few pods are running state, few pods are in pending state, few pods in crash loopback, few pods are image pullback. So those things we will discuss in the coming session, like what is the root cause of the issue, what is, how do we fix the issue. Those things we'll discuss later. Now I'm discussing about like which pod is running on which node. So those things we can run by using this command. So kubectl get pod hyphen o wide, and you can see here. So one Jenkins, like this Jenkins pod running over this worker node. Now I'm going to bring down this worker node. Let's see what are the impact. Okay, suppose our kubelet is down over this worker node. What are the impact? Okay, so kubectl get node. So there's two command, cordon and drain. Kubectl cordon. So cordon. So let's see the status kubectl get node. So now you can see like no pod will be scheduled over this worker node. Okay, this is in the scheduling disable, like no new pod no any pod will be scheduled over the worker node 6. Okay, so let me see kubectl get pod hyphen a. If you run this command kubectl get pod hyphen a, so this will show the list of all the pod in a cluster. Okay, so you can see a lot of applications are running here in this cluster. See, a lot of pods are running there. And if you want to see which pod is running on which worker node, so you can see here. Let me apply the grep command. ctl get pod hyphen a. So these are the list of application which is running over this worker node 6. Okay, now we are going for this scenario. I am bring down this node. Let's see what are the impact. So here I have cordon, I have drain. So cordon means like there's two component, cordon and drain. So once you do the cordon, like no new pod will be scheduled over the worker node. Okay, and drain means once you run the drain command, so all the pod will be migrated from this worker node to second worker node. Okay, so this thing we'll discuss in coming session also. Okay, so here we are getting error like you are unable to drain the node. So what is the root cause? So you can run this command like, okay, pending node to be drained, kubectl get node. I'm using this one, so might be there is running the daemon send, that's why they are not me to allow. So we have to also ignore the daemon set. Let's see. So now you can see evicting, like they have migrated all the pod to the new node. So let's see kubectl get node get pod. kubectl get pod. Now you can see all the pod is running on the node number 7. See, in the earlier few seconds ago when we run this command kubectl get pod, someone joining. So what in the few seconds ago we can see this Jenkins application is running on the node number 6. Now you can see once I have drain out, so all the pod is migrated to the node number 7. So this is the impact, like if you kubelet down, then all the pod running in this worker node they can migrate it to the worker node 2. Okay, So this is the impact. Got it. So in the Kubernetes there are two types of like Kubernetes. One is bare metal and the second one is managed Kubernetes cluster. So in the bare metal, what we have to take two virtual machines. Suppose this is I am going to install the bare metal cluster. Okay, so first we have to take one virtual machines, then I have to take another virtual machines. So for bare metal, at least you have to take three virtual machines for the master node and two worker node for to deploy your application. Bare metal Kubernetes cluster. So in this bare metal Kubernetes cluster, what we have to do first, we have to set up the master node. Like we have to create three master node. This is the minimum requirement when you set up the bare metal Kubernetes cluster. And this is the worker node. So here, like in my project, what in the project what my company did in the last 4 5 years back. So they take the 5 virtual machines from the Azure. So they have created the five. They have five virtual machines. Okay. So on the 5 virtual machine, they have created the set up the worker node and master node. Okay. So they have created 3 master node and 2 worker node, and on the top we have deploy our application only on 2 worker node, because on master node we can't deploy our application pod. Okay, so we have to deploy our application pod only on the worker node. So this is the like architecture of bare metal in my project, previous project. So here what is the issue, like you have the very cost is this is very costing, like they will impact our project cost, because we have to pay the 5 virtual machines, 1 master node and 1 worker node, because my application only running over the worker nodes. So that's why we are migrated on-prem Kubernetes cluster to the cloud base. In the cloud base you don't have to manage this master node. These all take care by the Microsoft or the provider. So in the Azure, the Microsoft will take care. So in the Azure, the Microsoft will take care this part, this master node component. We don't like worry about the component, like if etcd down, if the scheduler down, if API server down. So all the hectic they can take care by the Microsoft. So that's why like it's advantage, like we are not responsible to manage the master node, and it's also very a cost up to cost it's very higher cost, because we have to pay the 3 virtual machine extra. So that's why we have migrated our bare metal cluster to the cloud one. So in the cloud one, what we have to just purchase 2 virtual machines, like when you are going to create a Kubernetes cluster. So at the time you have to just define the worker node, like how many worker nodes you have to use in the cluster. So you have to just define the node count. If you go there in the Kubernetes cluster, so this is the pass service by Microsoft, like you have to just run in the search bar and run Kubernetes service. So this is the service given by the Microsoft, and you have to just go and create. Okay, create Kubernetes cluster. So I am already running here. Let me increase the font size. So I am using the managed Kubernetes cluster. So this is the managed Kubernetes cluster where we can manage only the worker node. Okay, let's remove the cordon, uncordon. So this is the command to remove cordon and uncordon. Now both of the worker node is up and ready state. So this is the managed cluster where you have to manage only worker node. Okay, you have to just go to the portal and you have to deploy, you have to create the service. No, that is very slow. So here you can see the node pool. So in the node pool you have to just define the number of the worker node, like how many worker nodes you required for your application. If you see here, manual. So here you have to define the two. If you define the two, means two worker node created. If you define five worker node created. Okay, so as per the project requirement or as per the architecture, like how much worker node you have to want and what are the size of the worker node. Okay, so you have to choose the size, like how many CPU and memory assigned to this worker node, so that your application running over there. So these are the under the capacity planning. Okay, so before, if a new application on board over the cluster, so you have to check with the application team, like you are deploying one of the pod, so how much minimum uh, and maximum memory required for this application. So based on that you have to create a cluster. So suppose you have meeting with the application team and they want to deploy the 10 application. Okay, 10 pod they want to deploy it, and each pod like they want suppose one pod needs 10 GB. Okay, so if 10 application deployed, then you have to need 100 GB of memory. Okay, so you have to create uh, 4 worker node with 30 GB. Okay, 120 GB will be there. So if in future if you want to onboard more worker nodes, so you have to increase the worker node also. So those things we will discuss in the coming session, like how do we scale up the cluster, how do we scale up the application. So those things we'll discuss. Right now just we are discuss about what is managed Kubernetes cluster and what is bare metal cluster. Okay. Yeah. So in the managed cluster, we have to manage only worker node. We are not to worry about the component of master node. So those things, like if any issue, if like in my past experience also, like the we are not able to deploy the new pod over the worker node. Okay, so we have to raise a case with Microsoft. So Microsoft check like their issue with from their end, so they have to fix the issue. Okay, so in this way, like you can also raise a ticket with the Microsoft. So similar way, the Amazon also provide the managed Kubernetes cluster like EKS. That here in Azure we are we have the name is AKS, right? So same in AWS we have managed Kubernetes cluster is EKS, and also in Google Cloud also providing the platform is GKE, I think. Yeah, GKE, Google Kubernetes Engine. So these three are the popular provider which they have provide the managed Kubernetes cluster. So most popular is Azure AKS, because all the application already running in the Microsoft based like operating system. So that's why like most of the company move to Azure AKS, like they have migrated all the resource to the Azure AKS platform. Okay, so this is the difference between bare metal and the managed cluster. So in the bare metal cluster you have to manage all the master component like kube scheduler, kube API server, scheduler, controller, everything. But in the manage you have to manage only worker node. Okay, so you can see here also. Yeah, so in the bare metal, if you see run the command kubectl get node, so you can see here the control plane, right? So once you run the command kubectl get node, you will see the control plane is there, the master node. Here you can see the master node. But when you use in the manage Kubernetes cluster, you can see here only the worker node, list of the worker node. Okay, so understand in this topic like what is managed cluster, what is bare metal cluster. And it's very easy to manage the cluster also, like if they have providing the auto scaling method. So if in future like you have some capacity issue over the cluster, so automatic the new node will be added in the cluster. New node will be added. Suppose you have in future you have deploy more application. Okay, so you it's automatic, like within a second the new node will be come up in the cluster. So this is the auto scaling. If you create a cluster at that time, they were asking about you are enable the auto scaling or not. Okay, let me show you. So here you can see auto scale. So once you mention the auto scale, so you have to define the minimum node count and the maximum node count. Like if the load is increases in your Kubernetes cluster, so automatic the new worker node added in a cluster, and you have to define the maximum node count, like it the new node added in a cluster up to 20 node. So maximum is 20 node. So you have to define 5. So maximum 5 node will be added when your load is when you have the capacity issue over the cluster. Okay, and if your load is decreases, then automatic your node will be removed from the cluster, and they can decrease up to what, like 1 node. So this thing we will discuss, like the how do we create the cluster or what. So is there any confusion on this architecture part? Hello?
No, sir.
And is difference between like what is managed cluster, what is bare metal Kubernetes cluster, is all clear?
Yep, yep.
Okay.
Tariq, just checking if do you have any slides or notes that you might share? I mean,
Yeah, I have slide I will share, like this one, like what is Kubernetes, what is container runtime, what is etcd, controller, kubelet, those I will share. The Docker image.
perfect. Yeah, thanks. Yeah, thanks.
And I will also share the architecture diagram for the reference, so you can follow the same one. Okay. So
Sure, thanks.
you have created the account, Azure account.
No, I'll create one.
You already know how do we create. First you
Yes.
have to go Azure free account and create your Azure free trial. Try Azure for free. So they are giving the 1 month free subscription. So in 1 month you can use, and after 1 month it automatically disable the subscription. Okay, so you have to follow this one. Okay, and you can create. So tomorrow we will like discuss about how do we create a cluster and we can perform. Okay, and let me show you one more thing. So in the coming session also we can discuss, we can create a cluster and we can learn the simple command what is like kubectl get node, kubectl get pod, kubectl get node. So it will get the list of all the worker node. So if you run this command kubectl get pod, so they will give the list of all the pod. Okay, so kubectl get pvc. So pvc topic also will discuss in coming session, what is pvc, what is volumes, and how do we create the volumes, and how do we see the data inside the volumes, and how do we import this pvc to the different pod. Okay, suppose your pod is crashing and you want to keep your data safe, so how do we use this one. So those things we will discuss in the coming session also. Suppose your pvc are are stuck in pending state. Pending state means your PVC is not in active state. So how do we fix this issue? Like how do we make this PVC online? Okay, and we will discuss about all the issues like what is image pullback error, what is the crash loopback, what are the pending state. So those things we will discuss in the coming session also. And I will also show you like some real time, like this type of issue I face in my project. Like you can see here, one of the volumes has been full, like 89% full. So how do we fix this issue? Okay, the same we have to find one of the application are frequently restarting, like 300 times is restarted. So what is the root cause of the issue? Okay, how do we check the logs, how do we read the logs? So those are the discuss we can in the coming session. So today just we started from the basic one because you all are beginner. Okay, so you have to go through it about the theory part, and tomorrow we can discuss more about the practical, and we can discuss all the related object how do we create the YAML file, what is manifest file, what is pod, what is service, what is the volume, what is PVC. So everything we will discuss. Okay, or we can start today about the Kubernetes cluster. What you suggest?
So I don't have Azure account ready.
Yeah, that's why once your account ready, you can also do the practice. You can create the cluster, and then we can proceed the similar way. You can also deploy. I will share the manifest file. You can also deploy, and here I am also deploy one of the application, kubectl get ns. So I will discuss about what is ns, what is namespace. Okay, so namespace just like a logical container, like a resource group in Azure. So similar way in the Kubernetes also the namespace. Namespace is just like a container. You can say in the simplest way it is a box. Okay, so this is the namespace. So this is namespace. Inside this namespace you have to create the pod. Okay, you have to create the service. So these are the components which are responsible to run the application. So you have to create the pod, you have to create the service, you have to create the PVC. Okay, so these are the main components to run the application. Like you have to create the replica set, you have to create the deployment. So those things we will discuss in detail with all the names. Okay, so the purpose of the namespace like to manage the project. Like sometimes sometimes you have one cluster and the multiple teams are working on the single cluster. Okay, so that's why we have created the namespace. Like suppose I'm going to create the one namespace for the monitoring team. So kubectl create ns monitoring. So you can see the namespace created with the name of monitoring. So kubectl get ns, and here you can see where is the monitoring. Yeah, here you can see my namespace created. So in this namespace we have deployed the monitoring related only application like Grafana, Prometheus. Okay, so multiple monitoring tools are there. So we have deployed our tools monitoring related application deploy. We have monitoring namespace, and we have segregate our project in a single cluster. So that's why we need the namespace. Like we can give the different teams are using the same cluster, so we can segregate by using the namespace. So in the single namespace you have to run your application. Okay, so here I'm using this one, the dev namespace. If you see here kubectl get pod -n dev, so it means they will show the list of all the pod, all the application inside this namespace. Okay, so in this namespace we have 1 2 3 4 application runnings are there. Okay, this is the e-commerce application. So I want to access this application. So what I told, we have to access the application via service. So we have already created the service in this namespace. So you can see here I have created one load balancer service. So this thing also we will cover in the coming session. What is service, how do we create load balancer. So I'm just explaining the namespace. What is namespace? So in the single namespace you have to deploy each and every component in the related to the application in the same namespace. You can, if you create the pod in this namespace, right, you have created pod in dev namespace and you have created service in different namespace, so it won't work. Okay, so you have to make sure the all the component which are responsible to run the application you have to create in the same namespace. Okay, so here what I have deployed one e-commerce service. Okay, and we have created the load balancer service. Now I am going to access this service via the load balancer IP. So now you can see my e-commerce website has been accessible, and here you can see you can do shopping, you can add the cart. See here I'm going to add, you can see the count is added, add, and you also go to checkout. Here the order submitted successfully. So in this way, like you can also deploy the web app and you can do the perform the test lab in this way. Like so the motive is to explain this thing, like each and every object related to the same application in the same namespace. Okay, and this is a very simple command to create the namespace. kubectl create ns. Suppose I am creating the production environment, like production based project. So kubectl create ns. So prod already there. If you see here, prod namespace already there. So now I am going to create the prod2. So prod2 is created. So this is the command. So once you do the practice in your lab, you are handy with all the command. So right now you are very difficult to learn all the command. Okay, once you do the practice in the lab, so it's handy. Like what are the, you have to first noted all the command in your notebook, like what is the command to see the list of all the pods. So you have to run kubectl get pod, and you want to see particular namespace, then you have to define the namespace. Okay, so similar way, if you want to see the service, what is the command? So kubectl get. So this is the common command, kubectl get. This is the if you want to see anything, like run kubectl get. So kubectl get ns, you can see the list of all the namespace inside the cluster. So similar, you have to run kubectl get pvc, then you can able to see the volumes, like in the Kubernetes volumes. So if you run to see kubectl get svc is service, then you can see the list of the service. Okay, so in this way, so you have to first you have to noted all the command. Okay, and you have to do the practice in your lab also, then you will get the handy. Okay, got it?
Yes.
And this is also the command kubectl get node. So you will get the list of the node. Okay, so do you want this command? Shall I share? So I will share the
Yes.
history one so that you can do the
Yes, please.
practice also. So the get command also, like if you want to see, like right now you can see only if you run this kubectl get pod. So this now means like no namespace defined for this application. There is no namespace. This is the default one. Okay, so if you want to see all the pod which is running inside the cluster, so you have to run this command kubectl get pod -a. -a means it will list all the pod in a cluster. So here you can see a lot of applications are running there. So similar, kubectl, you want to see like which pod running on which worker node, that I have already explained. Like you have to run this command kubectl get pod -o wide. So you can see the IP address of the pod also, and you can see the node, which node is running. Okay, So in the coming session also I will show you how do we check the logs of the pod. Like sometime if you are getting this type of issue, one of the pod are in crash loop back. So how do we uh, troubleshoot this issue? Like how do we check the logs of the pod and how do we find what is the root cause of the issue, that we will discuss in the coming session. Okay, so kubectl kubectl get pod. So you can also delete, you can also use this command to delete. So kubectl delete, kubectl delete pod, and you have to define the name of the pod and just click on it, then your pod will be deleted. Okay, so this is a very small command, so you have to do practice in your lab. And if you want to delete, like suppose I'm going to this namespace, so kubectl get pod hyphen n. So you understand now what is namespace? Hello?
Yes.
Yeah. So in this namespace we have, if you want to see what all the objects are there in the namespace, so you have to run this command kubectl get all hyphen n tomcat. So get all means it will show the list of all the component, like all the pods are there, what are the deployment and the replica set. So everything they can show by using this command kubectl and get all command. Okay, so now if you want to delete all the resource which is inside this namespace, so you have to run kubectl delete all hyphen all hyphen n tomcat. So they will delete all the resource inside this namespace. So you can see now my namespace has been empty, there is no resource are there. It's terminating state, it is deleting. Sometime when we are going to delete the resource are not deleting, they are stuck in terminating state. So how do we fix the issue? Those things we will also discuss. So if you see here, these things I have covered one of the use case. Even this issue I face in my environment also. So here you see I am going to delete the PVC and it is stuck in the terminating state. Okay, so how do we fix the issue? So I will share the solution, like resolution, how do we fix the issue. So those things we will discuss in the coming sessions. So today we just start from the basic one. So you will first you have to create the lab and then we will discuss about all the thing. I will share all the manifest files. Okay, now you can see there is no resource found in this namespace. It means I have deleted all the resources. Got it? Hello? So it's clear?
Yes.
Yes.
Okay, so let's copy all the command list and we share with you. Okay, and I will share this document also about the architecture. We will discuss today about the architecture of the cluster, and we also discuss about the managed node, how many types of clusters, and we also discuss about the pod and namespace and few commands like the basic commands. Okay, then we can,
Okay.
yeah, we can meet once you have to ready your labs. Okay, so we started the batch the alternate, like today is Monday, then we can meet up on the Wednesday. Okay, so that 1 day gap, so then you can also do the practice and the next day we can come up with your doubt and we can proceed for the next session. Is it okay? That we can
Yes,
start
sir.
with alternate day, like today is Monday, then we can meet on the Wednesday, and then we can meet on the Friday, and on the weekend also we can continue for 1 day.
Sure.
Okay, then
Fine.
the next topic we will discuss about how do we create the Kubernetes cluster and how do we deploy our application. And first we can start very small application, then you can go with this the e-commerce website. Like I will share the manifest file. So if you see here, I have already copied this manifest file. So those things we will share, and you can also do the practice. Okay. So in the coming session, like we have created the one virtual machine, and this is the agent machine. Okay, let this explain also like how do we connect. So suppose this is this is the cluster. So how do we connect this cluster? Tell me. Suppose this is your cluster. So how do we connect?
You have to use kubectl, right?
Yeah. So this is your you have to create one virtual machines. Okay, this is your jump host. We can say jump host in the organization. The jump hosts are in the same customer network. So that's called we are calling the jump host. So from jump host, we have to install our kubectl plugins here. Kubectl plugins we have to install. So once you have to install kubectl plugins, then you can able to connect. You have to run this command, the authentication method. If you go there, once you have created the Kubernetes service, so there is option connect. So this is the credential file, like they have the all the details, like which resource group you are going to connect, which cluster. You have to define the name of cluster, because in the real-time environment you have 100 plus Kubernetes cluster. So you have to run this command like that. I will this credential. So in the credential you have to define the name of the resource group, you have defined the name of the cluster name, and then you have to run. So right now if you see here, so kubectl, this is the command to check which cluster you have connected through the jump host. So this is the command kubectl cluster info, and you can see here this is the cluster you have connected. So AKS prod 3. Okay, this is the cluster, and this is the list of all the all the application running over this cluster. So run this command kubectl get pod. So this is all the application running on this cluster. Now I am going to connect the another cluster. So how do we connect? Okay, so for that we have to go this cluster. So this cluster is stop, so we have to start. So I think they are in progress to start boot up this application in this cluster. So you can see it in running state. So you have to go to connect and you have to run this command. So this is a command to connect the cluster AG AKS get credential, and you have defined the resource group. So resource group, you are aware about resource group? What is resource group? Are you familiar with this term resource group in Azure?
Yes.
Okay. So now you can see, let's see the kubectl cluster info. Now you can see the earlier we have connected with different cluster, the AKS prod 3. Now you can see I have connected with different cluster, AKS prod 1. Okay, so if you see the status of node, so kubectl get node. So no node found, because still the my cluster it is in progress to boot up. So this is also the free version. So you have the limited quota, like you can't create the you can't create the 3 4 Kubernetes cluster. So you have to create only one Kubernetes cluster and one virtual machines. But in the real-time environment, like you have created as per the requirement. So in my case, I have 50 plus Kubernetes cluster in my organization. And also we will discuss about in the coming session about the Prometheus, like how do we monitor, because in the environment you have 100 plus cluster, it's very hard to manage all the Kubernetes cluster. Like if any issue if any issue happened over the cluster, how do we notify? So that's why we have to set up the alert mechanism. You can see I have set up the alert over my email, and I got a lot of alert, like some pods are down or some issue over the cluster, then you will get a notification. See here the fired, and you can get the detail of the cluster. So you have to go to do your jump host and you have to connect your cluster, and you can see check the status of this pod. So here in this alert event, in this alert message, you can get the list of the cluster, list of the pod which having the issue. Now you can see my node is up. See, your node is not ready, and it will take some time to come up. So in this way you can connect the another cluster and you can see the status of the application on the second cluster. Okay, so once you have created it, still in cluster in starting phase. And this is a registry. Registry is the service in the Azure also, where uh, we can manage our all the image. Okay, that those things we'll discuss in the coming session. That one very advanced one. So now you can see my cluster is in running state. So might be this node will be come up. Now you can see my node is come up and it is ready state. kubectl get pod, and you can see the status of all the pod here. So we have very few pods running in this node, in this cluster. So kubectl get pod -a. So this all the application running here. So once you have created cluster, so at that time this is the by default pod. Okay, the kube system. These pods are related to the control plane. Okay, the kube proxy, core DNS, Azure CNS IP. So this is the by default. Okay, so this is by default pod is created when you create a new cluster. So at that time you can see the automatic the kube system namespace has been created, and this is the by default pods. Okay, and this is the application related pods, the tomcat veloro. This is the backup tool application. Okay, by using this application we have to take the backup, we have to do the work for the migration also. So this is the backup tool. Got it? So do you have any question? Hello?
No, sir.
Uh,
As of now, no question.
Okay, yeah. So then for this time we have to close because you haven't created any the what free trial version. So so tomorrow if you have any issue like to create the account, you have to ping in the chat, like you are not able to create the account, then we will give the support. Okay, and Wednesday we can come the same time. Okay, 8:30. Got it?
Okay, sir. Yeah.
Mm-hmm. Where is the stop presenting? Yeah, okay, then we have done for
Thank
the
you.
day. Okay, so thanks for participating. Thank you.
Thank you.
Yeah.
Good day.